Welcome to this cosmic adventure where a visitor from the edges of the sky takes us on an incredible journey. And in this introduction, I invite you to stay until the end of this story without saying it directly, because this narrative holds unexpected and thrilling revelations, and you will see why it is essential not to miss anything as we explore together the discovery of third interstellar object and the mysteries it reveals. On our channel, we love to tell stories of interstellar journeys, and this time we are going to talk about a very special comet that crossed our solar system for the first and the last time. Its name is Interstellar Comet Atlas, and its path goes beyond everything we had seen before. It is a true messenger of the stars that makes our imagination vibrate. Everything began when the Atlas Network telescopes in Chile detected an unusual glimmer in the night sky, and the astronomers noticed a hyperbolic orbit that clearly indicated that this comet would never return, and that it came from outside our solar system. This discovery made this celestial body the third interstellar messenger, after Oumuamua and Borisov. The comet was christened 3I Atlas, and quickly the scientists understood that it was coming from the direction of Sagittarius, and retrospective observations showed that it had already been photographed a few weeks before. And this unexpected phenomenon fueled the curiosity of astronomers and space enthusiasts who wondered what secrets this galactic traveler could hide. This icy body appeared at more than 420 million kilometers from the Sun when it was discovered, and its trajectory was to bring it to a minimum distance of 1.5 astronomical units from Earth, and its high speed indicated that it was crossing our system with enough energy to escape forever. And this dynamic confers on this unique object an aura of mystery and rarity. The Hubble Space Telescope was quickly mobilized to observe this visitor up close, and its first images revealed a nucleus that could measure between a few hundred meters and several kilometers, as well as a plume of dust stretching into space. And these data suggested that the core size of the comet was larger than that of Oumuamua and comparable to that of some comets in our system. The scientific teams then called on the James Webb Telescope and the Spherex Observatory to analyze the chemical composition of this body, and by scrutinizing the infrared light, the researchers hoped to detect volatile molecules and rare elements. And this observation was part of a coordinated effort to understand how interstellar comets behave when they are exposed to the Sun. As the comet approached the Sun, other space missions joined the effort, and probes such as Psyche Stereo Lucy and Punch observed the visitor from different angles by stacking images or shielding their instruments from the Sun in order to detect the tail and coma that formed despite the low brightness, which demonstrated the efficiency of collaboration between missions. Approaching perihelion, the comet produced jets of gas and dust that unfolded into space, and measurements suggest that it was ejecting massive amounts of water, equivalent to millions of tons per day. And these jets manifested themselves as luminous structures that Hubble and other instruments followed in real time, and the intense outgassing provided precious clues about the composition of the nucleus. Missions in orbit around Mars, such as MAVEN and MRO, took advantage of their position to observe the comet as it passed behind the Sun from Earth's perspective, and their ultraviolet spectrographs detected a halo of hydrogen and oxygen around the nucleus, indicating an abundance of water vapor, and these data provided a precise measure of water production and allowed the study of the exotic composition of this comet. The Parker Solar Probe also had a close view of the comet by filming the dust and gas it released during its passage near the Sun, and the WHISPER instrument captured the evolution of the tail and the appearance of an anti-tail directed towards the star, which results from the interaction between the solar wind and the dust particles. And this mysterious anti-tail demonstrates the complexity of the interactions between the solar plasma and interstellar materials. Other instruments such as XRISM and Europa Clipper added observations in X-rays and ultraviolet confirming the presence of carbon, nitrogen, and oxygen, and revealing fine structures in the tail. And these contributions show that multi-wavelength observation is essential to fully understand an object from elsewhere. At this point in our narrative, we have covered about 1/4 of the story, and it is the ideal moment to remind you how precious your support is. And if you enjoy this cosmic journey, do not forget to subscribe and activate the bell to strengthen our channel, because each new subscriber supports us and allows us to continue exploring the universe. And think about checking the link in the description to participate in our contest. This call to action is discreet yet impactful. Let us now continue our exploration, because there is still much to discover. And the comet reached its perihelion towards the end of October, approaching a little more than 1 astronomical unit from the Sun. And this proximity caused a surge of brightness that delighted observers and made the comet visible to the instruments dedicated to heliophysics. And the bright perihelion was a key moment of the mission. After rounding the Sun, the comet became temporarily invisible from Earth due to the glare of sunlight. However, probes located elsewhere continued to observe it, and the hidden phase of the comet revealed how its nucleus reacts to changing solar irradiation. In November, the Hubble mission obtained new images of the comet at about 280 million kilometers from Earth, and Hubble tracked the visitor's rapid motion, transforming the background stars into luminous streaks in the photos. And these images testify to the precise tracking required to observe a body moving rapidly in our sky and allow us to see the rapid motion of this object relative to the stars. As the comet moved away from the Sun, its production of gas and dust gradually decreased, and instruments like SWAN on SOHO measured a decline in water production by monitoring the glow of hydrogen in the halo. And this decrease indicates that the comet is cooling and that the volatile ices are sublimating less. And this diminishing activity marks the transition between the active phase and the silent phase of the comet. In December, the comet made its closest pass to Earth at about 168 million kilometers. That is a little more than 1.5 astronomical units. And although this distance is large, it offered amateur observatories an opportunity to follow it in a dark night sky. And astronomy enthusiasts around the world pointed their telescopes to capture this close pass and immortalize this rare moment. The media and several online projects organized live broadcasts to share the latest views of the comet, and an event on the 16th of January marked a collective farewell as the comet continued its journey toward the confines of the solar system. And these broadcasts gathered thousands of people and strengthened the community bond around skywatching. At the same time, scientists analyzed variations in the jets of the comet, and some jets seemed to wobble like a spinning top, while others formed a spectacular anti-tail. And these oscillations probably reflect internal structures of the nucleus and variations in rotation. and the study of these oscillating jets helps to understand the mechanisms of comet outgassing and provides information about the constitution of the nucleus. Dynamic studies were also carried out to determine the comet's future trajectory after its passage near Jupiter at the beginning of spring, and calculations show that it will pass at about 50 million kilometers from the giant planet without being captured, and this passage will make it accelerate slightly. And after this encounter with Jupiter, the comet will leave our solar system forever. The hyperbolic orbit of the comet means that it had already been traveling for millions of years before entering our neighborhood, and its high speed and direction suggest that it comes from a distant region of the galaxy, perhaps ejected from its native system by gravitational interactions with a massive planet. And this idea nourishes speculation about the cosmic origins of these travelers and the diversity of planetary systems. Spectroscopic analyses conducted by the James Webb and other telescopes have identified compounds similar to those in comets in our system, and this similarity indicates that the basic chemistry in the formation of comets could be universal, which means that the fundamental building blocks of life may be common throughout the galaxy, and that this universal composition reinforces the idea that life could arise everywhere. Scientists have also predicted that a rare alignment between Earth, the Sun, and the comet would produce an opposition surge at the end of January, revealing the structure of the dust grains. And this rare alignment will offer a unique opportunity to better understand the properties of the surfaces of interstellar dust particles. The set of observations orchestrated by various missions represents a model of international collaboration, and each probe has contributed by providing complementary data, and this synergy makes it possible to share knowledge with the scientific community, and international collaboration is at the heart of this success that inspires future space exploration. Amateur astronomers and enthusiasts have also played a crucial role by tracking the comet with their instruments, and their observations improved the precision of its orbit. And this citizen participation shows that astronomy is an open science where everyone can contribute to the discovery of celestial wonders and feel the thrill of discovery. The comparison between 3I Atlas and the two previous interstellar objects helps us to understand the similarities and differences. And Oumuamua was elongated and lacked a visible coma, while Borisov resembled an ordinary comet. And 3I Atlas lies between the two, with a modest nucleus and high activity. And this comparison between objects offers a representative sample of the diversity of interstellar travelers. Although some have speculated about artificial hypotheses, radio and optical analyses have not shown any structured signals, and this confirms that this comet is a natural object from a distant system rather than an artificial construction, and it strengthens our understanding of natural bodies coming from other systems. As the comet moves away, it gradually loses its brightness and will soon become invisible to our instruments. But the data collected will continue to provide information for years, and scientists will analyze the spectra and images to draw conclusions about the composition, dynamics, and history of this final journey through our neighborhood. We are approaching the conclusion of this narrative, and I thank you for having followed this odyssey to the end. And by retracing the story of this messenger of the stars, we have explored the behind the scenes of research and the technologies that make it possible to capture these phenomena. And this adventure reminds us that the universe is vast and that each cosmic story brings us valuable knowledge. Thus ends the saga of 3I Atlas, an interstellar comet that offered us an extraordinary spectacle and rich data, and its passage will remain engraved in memory as one of the rare moments when we were able to observe an object from elsewhere. And continue to follow our channel for other cosmic stories and share this end of journey with those who are curious about the sky.